Okay. Thank you for coming today, and thank you for bringing your presentation to share your knowledge and experience with us. So are you ready to begin your presentation?
Just you're talking to me, Drew?
Yes.
Yes, yeah, I'm ready. Yes.
Okay.
Can I share my slides?
Yes.
Okay, so the title of this study is AI Tools and Conceptual Fluency in English as a Second Language Learning. The focus of the study is on Vancouver campus, FDU Vancouver campus. The newly admitted students mostly on Vancouver campus are international students. Once they are admitted from different countries in the world and they arrive at Vancouver campus, they're supposed to take placement test. Beside that, they have also have their IELTS score or TOEFL score or other English battery tests, and based on that, they are placed in different EPS courses. We have EPS 5099, EPS 5299, and EPS 6299. And depending on the grade they have from their placement test, they are placed in such courses. What we observe among language learners, ignoring which country they're coming from, is that many of them are learning English in classroom settings and accordingly based on a textbook English, which is different from the natural English awareness expected. So the gap between real world and the classroom or textbook English and what EFL speakers need to understand for the full meaning behind real world expressions, we see that these students normally have a language which is grammatically correct, but pragmatically ambiguous or incorrect. And this puts them sometimes in tough situation. Classroom language learners have received good scores on exams such as IELTS or TOEFL, but what we observed in pragmatics is a sort of incompetence. Huang has a research and he believes such misunderstanding and failure in communication seem to be due to the cross-cultural discourse differences. And this is because the pragmatic conventions of native speakers and L2 learners may differ substantially. Here, it's very important to find out about what verbal fluency is and what conceptual fluency is. And the difference can highlight what we observe about those who learn English in classroom setting and those who learn English through interactions with authentic sources. Verbal fluency or formal fluency is the ability to manipulate the formal grammatical units and formulaic communicative structures of the second language. While what conceptual fluency theory gives us is that best we can define it as its central objective, and it is to ensure that learners have access to the conceptual structures inherent in the target language and culture in a systemic, sequential, and integrated fashion with other areas of language learning. Accordingly, the definition for conceptual fluency can be the ability to access the appropriate source domain, and the programming of second language discourse that allows for a non-literal allocation of meaning to language forms. Lack of exposure to authenticity and learning English based on textbook can support students to develop good skills in reading, writing, listening, speaking. They can develop good skills in communicative competence. They have good lexical background, but concept and conceptual development is the focus. When the structure of concept in both languages are in identical ways, the students' discourse texts are culturally appropriate because what they have from mother tongue and target language, which is English language, they're matching. And when they are not, the student text manifests an asymmetry between language form and conceptual content. This can lead to some conceptual errors. Those who are dealing with international students in different courses, or those who are dealing with immigrant, have good examples of such errors. Here, I'd like to emphasize the role of metaphor in development of cultural concept and in supporting conceptual skill development. The research in the cognitive and social sciences and languages reflect or encode concept on the base of metaphorical reasoning. And this is something which has been done and studied over time. So we have a direct relationship between culture and conceptual metaphors. In this connection, Lowe says that few would deny that we want learners to develop metaphoric competence in the L2. The hard part, that the question is how to perform that. Also, Landholf and Thorne have the conclusion that conceptual metaphors are culturally structured models responsible for forming the relevant experiences and appear in linguistic expressions. So now the question is helping language learners with development of their conceptual learning. Here, one of the key answers is authenticity in L2 classroom. Language researchers insist that language learners should be in direct contact with the language through authentic interaction with the target language. And here, the role of AI tool is so significant. The experience of real life English that we need is gained through exposure and interaction with the authentic material through AI tools. For the history of conceptual fluency, Donizy says the inability of students to speak and write in ways that goes beyond the literalness of textbook and to use idiomatic and culturally sensitive phrasal structures of the second language has been the motivation behind several very pedagogical proposals starting in the 1970s. Conceptual metaphor theory and cognitive linguistics have led us to several frameworks for researching and having access to second language concept. Here, the role of AI in foreign language learning shows that almost there is no disagreement on the application of technology in order to boost educational goals. The involvement of technology in education and particularly in foreign language learning in classroom. So AI tools can help students to have a better exposure in classroom with the authentic sources required for their development. This study is based on Vygotsky's social cultural theory. So in simple words, Vygotsky believes that there should be a medium between the brain of the learner and the surrounding environment. And here, that tool, that medium is AI. In my class, during the fall semesters, in EPS 5099, I ask a student to write an essay on a certain topic with a number of words. And then for the second trial on a different session, I ask them to use AI this time and create a similar discourse. And after having both of these discourses and checking the metaphorical density of both discourses, the density of metaphorical expressions in student written discourse showed that those who have exposed themselves to AI and then received support through authentic sources had a higher number of metaphorical density. Of course, I have not done the study complete yet. I need to run statistics on the relationship between the number of the metaphorical density in the one with AI and the one with no AI, and then see if the difference is meaningful. However, as the conclusion, I'd like to emphasize that I have used different computer-assisted language learning techniques in my classes in order to boost this tool and this medium Vygotsky emphasizes to develop conceptual competence, and then authenticity has been the source of them. Some of the classes, they forbid AI in their courses, while I think that meaningful and significant interaction with authentic sources can lead to a better development of conceptual skills. Thank you very much. Thank you, Drew.
Yes, thank you so much. Do we have any questions? Chris?
So I've used some of the models available for second language learning. I know that tools like NotebookLM and other Google products have 84 different languages that they offer. But I can't imagine that all 84 are equally good. Do you have any experience with the variation from one language to the next of what are the strengths and weaknesses of these systems? I had a hard time just receiving all the question correctly, but if I got it correctly, I could say that whatsoever tools that helps the learner to have a better exposure with natural language, whatsoever the target language is, here the focus is English, of course, can support this medium of interaction. So in 2009, when I was doing a similar research, and it was online teaching between Middle East universities and then the instructors who were in Canada, and we were comparing the role of native speaker teacher with non-native speaker teachers in terms of helping language learners with conceptual development. The same result was gained. So the focus here is the right exposure and the right interaction. And when the rate of this interaction is higher, normally we observe that the language learning is better. I also just had some observation for those students who have entered Vancouver campus and had a higher rate of interaction with native speakers through their jobs, through the place of their life, sharing rooms. And then over time, in their written discourse, in their oral discourse, as I was very sensitive, I could see a higher degree of correct metaphorical density. I hope I could answer your question correctly.
Yes, thank you.
You're welcome.
Thank you so much, Maran.
You're welcome.
Good.
Hello. Hello.
Yeah.
Hello, everyone, or you guys. So my name is Duni Adenuga, and I'm from Kane University. So the title of this work is Guided Self-Regulated Learning via LLMs. See if I can get this out of. Sorry. Yeah. Okay, so the idea behind this work came from I started being an assistant professor about 2 years ago, and the class I teach is a intro to programming class. So one thing I noticed is that students really like using the systems, but I believe and they are novices, trying to learn this new programming language, Java in this instance. But when they use this systems, they have this confidence. They usually believe that they've learned the course material. But when they now get tested on it, that doesn't show up when they are assessed, regardless of how many cheat sheets you give them and all of that. So that learning process, there's a disconnect in a way. That learning process is not taking place, regardless of the confidence they may feel when they use the systems. So that was one aspect of why I was interested in this. And another aspect from talking to someone who tried to do this active learning approaches in class. One thing he used to do is that he would give students materials before class so that they read it, and he tests them on it in class, give them a brief quiz, but he noticed that students just completed it with generative AI instead. So that's part of them learning and then coming to class to have productive discussion. That was not happening. So the goal behind this is I started looking at how can that merge happen, right? How can we make sure we are still using LLMs and still sort of that guiding aspect of it? How can we insert them in the way we design LLM systems? Okay, so that's where this framework, this self-regulated learning framework comes in. So basically what this work is about is going by the framework to design this LLM system. So there are three parts of self-regulated learning. First is this forethought, where learning is planned, there are goals set in place, which is something the school environment, class environment offers, right? We start with the syllabus, and then we have all the things we want to teach, that sort of structure. We already have it, but how can we integrate it with LLMs? And then also performance monitoring, right? Monitoring students. And then the third part of self-regulated learning is self-reflection, right? Where students, self-reflect on, okay, what they allegedly learned. Are they thinking through the learning process, basically? So what we just try to do is create a system that has all this in place, as well as the LLM model behind it. So there are definitely existing self-regulated tools, right? But they're usually static, right? We tell students, write like a reflection essay, that sort of thing. But what generative AI brings into it, it can provide a more dynamic experience for students, especially for the type of class I teach that is an intro to programming class. I usually get students from different parts of the department, of the school, in fact. Okay. Okay, before we get to that. So what we'll be doing, what we are trying to do here is moving from the traditional way LLMs are created today to this more guided form of LLM systems. So instead of having this unstructured singular responses that we get from the systems when they are prompted, there's a milestone progression and bounded dialogue. We'll see what that looks like pretty soon. And also knowledge checks in between the learning process. And then handling of errors, right? When students say they don't understand something, what does that look like? And also not just assuming that just by providing the response, the student has sort of learned. How can we make sure we are getting knowledge about, did they actually learn this? So the system we created is called Study Assist, and it tries to follow all of this parts, or follows this whole process. Okay, so this is a diagram or a visual representation of what it looks like. So first, when the user, this time the student, first, creates an account with the system, they give it a major, they fill like a brief form about what their intent is, what are their interests, what level are they regarding programming, for example. And then the system generates 2 to 5 modules based on whatever topic they're interested in learning. And they go through this milestone progression while using the system. And then before they can move through each module, each milestone in a module, they have to fill out or answer a particular reflection question. And to move from module to module, they have to fill out a brief quiz. And the way the response they get from the LLM is designed, it takes note of the students, the brief form they filled when they signed up for their account, like their interests, so that when it's giving examples, it's tied to their interests. When it's giving exercises, it's tied to whatever they've learned prior. So that's the goal behind getting that intent assessment first. And then I already talked about the performance. So to move between each milestone in a module, they have to answer a brief reflection question that is based on, we'll look at, let me see if yeah. Okay, so they will answer a brief reflection question based on a brief description of what they are supposed to learn. And then to move from one module to the other, right, they have to also answer a brief quiz. So the goal is that, so this is the student version, and we've been working on the instructor version recently. So the goal is that this would be introduced in the class, and the teacher is able to keep track of as to how do students go through the modules, what scores are they getting with the quizzes, what particular parts, what milestones did they struggle with, what modules did they struggle with. So the goal is that I'm hoping I can, my plan is to sort of test this out in my intro to programming class coming in the fall, right? So this is the student version I'm presenting, but we're also working on an instructor version also. Okay, so we'll go through 3 parts of the system. So when the user, they enter, they create their account, right? We get their information about what their interests, like I mentioned. And then we try to sort of, I don't want to say mimic, so that it looks like the LLM systems they are used to also. So it's supposed to look like it so that they are still interested in, using it. So there's a studying and a revision aspect of this. So the revision aspect is more after they've completed a couple of modules, a couple of topics, they can always go back and see the past quizzes they completed or even complete a new one. But for the studying one, they will enter whatever they're interested in studying, and they will get this lesson plan on the right-hand side that they can either they can improve in any way they want. They want to make it, they want to reduce the number of milestones. Do they want more milestones? Do they want to delete a particular module? All of those sort of things. So they can do that in this request modifications box down here. And then they would accept that particular plan, that roadmap, that particular lesson plan. And one way we try to, keep their attention or keep them coming back, apart from the fact that we'll be introducing it in a class. So hopefully that structure would, make them want to use it. Another aspect of this is we introduce things like points, gems, that sort of thing, so that they are collecting that throughout the semester, and so that the teacher is able to sort of also reward that at the end of the semester. Another aspect of this is that we disabled the copy and paste for this box, right? So that they are not, copying and pasting from, just another LLM system. So they are just, all of this is just about, not in a way, guiding them to, apply cognition, just, to cognitively interact with whatever they are seeing. So that's the goal we are trying to achieve here. So when they put in their responses, so after a reflection question like this, when they put in their responses, the backend, tries to access, was it a correct response? Then they advance to the next milestone. If they put in I don't know, it tries to explain the same thing in simpler terms. If they give an incorrect response, it tries to reteach the same concepts. But if they end up failing twice, just moves them to the next. For now, that's the way we have it set up. It moves them to the next milestone. So the goal is that the teacher will probably notice that and, try to make sure to concentrate on that in class where they failed twice. And like I talked about, we keep track of all of these metrics, right? What was the accuracy rate? How long were they spending on the system? How many modules were they able to complete, before class? What's the quiz average? All of that, all of this information is also available to each of the students. And for the class, for the instructor version of this, the instructor will create a class, and then they will have multiple students in that class, and they'll be able to see, the class average, see the class quiz average, all of those things, see what modules students are struggling with, and that sort of information. Okay, so on the back end, the way this is created currently, right, it's just a multi-prompt LLM architecture for now. So we have this different aspects, different modules on the back end that we make calls to, make calls to this Grok API that is, and we run this Llama 3.3 LLM. So that is the LLM we send all of the prompts for each of these modules to, right? So the first module, the intent analyzer, is about getting this new user that has signed up for this account. What are they trying to do with this system? What is their major, their current year? Just keeping track of that. And then another, right now we actually have agents for each one, like the previous talk he had. So we have like agents for each of these modules. So we have a plan generator agent. That's the agent that, creates a plan based on what the user wants to learn, what the student wants to learn, and then it asks for modifications, whatever modifications they want to make to the plan. And then the conversation manager, just keeping track of the conversation as they go through each milestone. So the teacher module also, basically the content the students is given, That is what this agent tries to deal with. Then the assessment analyzer, the responses that the students provide, it tries to analyze it and make sense of it. And then the quiz generator, right? The quiz that they answer after every module to move to the next module, we have an agent that also deals with that. So we store all of this in a MongoDB so that, we are keeping track of sessions. So students can, maybe they complete one milestone today, they can come back tomorrow and just continue the same way. So we needed a way to keep track of all of those session states. So MongoDB helps us to do that pretty well. So we did a preliminary or a quick test on this. We put this on Prolific, and Prolific lets you select maybe if you want about a number of students. It's an online platform. So we were able to get about 55 students based in the US. We got they were from different backgrounds. So we gave them the system, we gave them access to the system and told them to complete 2 topics, Java programming, and also a topic they were interested in. And we evaluated them using, SUS, that's the system usability scale, NASA TLX workload, this pre-post knowledge gains, and then a satisfaction scale also. So I'm in HCI, so that's why it was important to also test this with people. So one thing we noticed, they really liked working with this system. We got the average score, system usability score, is usually about 68. That represents good. So we got about 78. So our participants really liked the system, and they were willing to recommend it to others. We also had high satisfaction scores. I want to read this quote here. Okay, so one of the quotes that we thought was that really goes with this line of learners actually like structured friction. So one of the participants said, I really like how quizzes give you questions from previous modules as well. It helps cement previous knowledge. I would look at the stats often if I continue to use the app. So, right, they like, completing those quizzes and going back to see, okay, I got, multiple good scores in all of the quizzes I did to move to different modules. Okay, another result that we got. So using the NASA TLX model, we had the participants, fill out a scale about the effort it took them to complete tasks on the system and the mental demand it required of them. So those were high scores, but at the same time, we also recorded low frustration. So even though they found the tasks, cognitively demanding, they still felt low frustration, right? That's a good scores, good metrics, because it's telling us that this is taking efforts, and for learning to occur, that's intense cognition has to be, activated. So we liked this sort of score. It's telling us that this was demanding, this was mentally demanding, but at the same time, they were not frustrated. They were aware of what they were trying to do, and they were willing to stay the course to achieve their goal. So this was another one of the results we got from Prolific, from our participants. And so to get knowledge gain, right, this was just, the first tests. If we actually did this, for example, when I do this in my class, I'll be able to actually get, before the semester starts, I get their current knowledge level, and then after the semester, I get their knowledge level. But for this particular study, we asked the participants before they, completed our system. We asked them different questions about Java, different questions about all of this, and this was the ratings. And then after they used the system, right, all of these were significant differences. So there was quantifiable learning gains or possible learning gains from the use of the system. Another question that we were interested in, because we had the participants use the system for Java, regardless of whatever their background was. And then we had them choose a topic they wanted to learn. So for the second topic, most of them chose, topics they knew already, right? And something we found The structural process did not need to change, right? But most people enjoyed learning their own topic much more than learning Java, right? Especially people that had no idea what Java was. So they really liked it. And then choosing the ability to choose their own topic, right, was another layer of agency that also motivated them. They were more likely to, okay, I know this topic. They were more likely to, want to critique things, answer those reflection prompts. And so prior experience definitely with the topic is a big factor in people's, willing to learn. And that also tracks with when people choose to learn also. And another reason why this first aspect may be important, right? So this is, for now, this is geared towards, learning intro to programming, but this can be useful in other classes also that are struggling to teach the more things like the social arts classes, the social science classes, those sort of classes that are, struggling to integrate LLMs, right? This can be something that we find a way for them to also adopt in those classes. Okay, so this is the last slide. So the goal from this was the student version of the system, but our aim is that we would create an instructor version also that is able to, aggregate multiple, so that the instructor is also going to be able to, make changes or influence the sort of things the students learn. So the instructor version we have currently, the instructor basically uploads their syllabus, and then the system tries to identify, smaller milestones that students can try to reach in between different topics. So that's and then the professor is able to update or change some of these milestones before it's released to the students. Also, the professor is able to, specify how many modules do I want to break this particular topic into, right? So that's what the teacher version is looking like for now. We are still, talking to more people to see what other things do they want in such a system. So the core part of this is that LLMs are, all of the systems are good, but if they need a sort of boundary in some cases, depending on wherever they are introduced. The sort of LLM that a novice, a new student needs compared to a senior, I believe should be different, right? A senior has probably taken multiple computer science classes, they have more ideas, they are more likely to be able to critique things correctly, while a novice will more likely just accept things. So I believe if we're able to, sort of, because at the end of the day, these tools, these AI models, they are malleable. If we are able to sort of, construct them in a way for a particular purpose, for a particular set of people, we'll get the best use of them and will not be losing things like critical thinking, things that are important for any society. So that's the idea behind this work. So yeah, that's the last slide. Thank you very much. Yeah.
So have you been able to parse with the student satisfaction, how much of it is that gamification with the points and the periodic updates of the milestones versus how much of the satisfaction and positive feelings is from the personalized and tailored nature of the LLM model?
Okay. Because the study that we did was short term, so I'll probably be able to give more informed response when I run the longer study. But so if I was going by the short-term study, I would say it's the personalized nature of the system. Even though some people were able to identify, they liked seeing, those germs, show up, they liked seeing those sort of things, but when they got to like the topics they were more familiar with, they really enjoyed that experience more. So I believe personalization, at least for now, is top part of this.
Are you running the Llama 3.3 just locally on hardware, or
No,
paying for a license elsewhere?
we are making like API calls and things like that. So yeah, but we're doing it through Grok. right? So
Oh,
yes, yeah. So we're trying to use like a cheaper. We're actually going to move to Gemini because I was able to get like credits recently, so we'll host this on Gemini for the longer study.
and is this something you're opening up to the public? Like, I know you guys are using it at Keen, but,
Mhm.
is this something that FDU faculty can
Good.
reach out to you?
Yeah, I think you could reach out. I want to test this more. So I just want to test it more, but once definitely I know that okay, even if it breaks, no, it won't be too terrible, then definitely I would open it up.
Okay.
Yeah, yep.
You know, when you were, designing your model for quizzes,
Mm-hmm.
why did you select the threshold of 60%? That sort of.
Yeah. I think I saw that in one paper, one educational paper that just said that paper also broke learning down into different levels, right? There's the generalization phase, there's the just accepting things that they just had like 4 levels. So one of the past scores there was 60%. So I think that was why I had put it there. Yeah.
Excellent presentation. I would like to really see the results of your study next year.
No problem. Yeah, definitely. Thank you.
Thank you so much.
Thank you.
Upload that, just for, to give a shot, check, this is what I want.
Yeah, that's what it's going to do.
That's small.
And that concludes our presentations for today. And thank you all for coming. And I know this has been a long day in our first symposium for FDU Center for AI. So again, thank you. It's we've learned a lot of new things, and the research and the collaboration is just going to be continuing into the future. And hopefully we'll have this as an annual event, and we'll bring out speakers, and they'll continue the research, and we'll just keep on growing and learning and expanding new knowledge, and to bring back new things that we can bring into our classrooms. Thank you all for coming today.